Good morning. Actually, it's afternoon for you, but morning for me right now. Today we're going to talk about what's called continuity. That is the next topic we are going to discuss for a few days. And today we're just going to talk about continuity from a graph. And it says in order for f to be continuous at A, and again that's what continuity means. It means the graph is continuous at that spot. The following conditions must hold. All right, first one, f of A is defined, and A is in the domain of the function. We'll talk about that in a second. We'll look at an example of each of these. Number two, the limit as x approaches A of f of x exists. And then the third thing that needs to happen for something to be continuous is the limit as x approaches A for the function is also equal to the value of the function at that spot. Now, it seems a little confusing when it's all in symbols and words, but it makes more sense when we look at some images. So let's look at the first rule. F of A has to be defined for something to be continuous. So essentially, an f of A is not defined. That would be when we're talking about a hole in the graph, all right? But it doesn't have any other spots at that point A. It just completely skips over. It doesn't jump to another spot. It just kind of be skipped over. So that's what we're looking for. We're looking for a hole or spot that's kind of been skipped. That means f is not defined at A in this particular picture. All right, second rule. The limit as x approaches A of f of x exists. So for this one, what's happening is the limit as x approaches A from the left-hand side does not equal the limit as x approaches A from the right-hand side. That's why the limit doesn't exist. Now, in this one, kind of remember rule 1, f of A is defined. So f of A is defined at this point. So it fits rule 1, but it doesn't fit the second rule because, again, the limit from the left would be different from the limit from the right. And the third rule. The limit f of x as x approaches A is equal to the value of the function at x approaches A. So for this one, the limit as x approaches A from the left does equal the limit as x approaches A from the right. Remember, it doesn't matter what happens at A. We're talking about what's happening right next to it. So from the left, as I'm really, really close to that spot A, or from the right, as I'm really, really close to it, they're lining up. All right, but what's happening is there's another hole at that spot. So holes are definitely something that gives us discontinuity. And at that hole, what we're seeing is that there's actually a value for A, again up here, but it doesn't match up. Again, in this particular one, let's just say, for example, that that was 1 and that was 2. Then again, the limit as x approaches A for f of x for our function would equal 1. But the value of the function at A would equal 2 because that's where the colored in spot is. So because the limit is different from the actual value at that spot, we have another point of discontinuity. And again, obviously, they're so obvious visually, but it's starting to understand what makes them discontinuous. So again, we have 3 rules that we're going to be looking at, and your work today is just to identify where the point of discontinuity is and which rule was broken. Was it rule 1 that was broken? Was it rule 2 that was broken? Or rule 3? And these rules are listed on your assignment today. That way you don't have to keep flipping back to this video. All right, that is it for today. But again, the start of a pretty important topic. So we'll be working on continuity for a few days. All right, good luck.